Hi everyone, welcome to the last video. In this video, we're just going to go through an example using cofactor expansion. So let's say that we want to find the determinant of a matrix 1, 5, 0, 2, 4, negative 1, 0, negative 2, 0. And we're going to use the cofactor expansion. Now, just like how I talked about before, you can use any row, you can expand across any row or any column. But my professor gave me a really good tip of advice when he said, you really want to choose a row or column that has the most amount of zeros. And you're going to see why. Now, let's say for the purposes of this video, you can either do the third row or you can even do the third column. For this video, we're going to do the third row. So remember, how do you do cofactor expansion by did I say column? How do you do cofactor expansion by column? Here's the formula here. So the cofactor expansion by column is the determinant of A, and let's say that this matrix is matrix A, is A1j C1j plus A2j C2j plus dot 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 plus ANJ CNJ. Great. Now we need to figure out what exactly are we looking at. We're expanding across the third column. So since J represents the column, our J is going to be equal to 3. So then the determinant of A is equal to A row 1 column 3, row 2 column 3. We only have one more row left, so row 3 column 3. Now, so let's fill in the formula with these elements. What is the element in the first row, third column? First row, third column is 0. The second row, third column is negative 1, C2, 3. And the third row, third column is 0. And again, anything multiplied by 0 is 0. So that really makes our formula simple. So now the determinant of A is equal to negative 1, C2, 3. But that's not all. So now we want to figure out what is C23. This is equal to negative 1 times, remember it's negative 1, have the formula right here. C23 is going to be equal to negative 1, 2 plus 3 times the determinant of A23. Negative 1, 2 plus 3 times the determinant of A23. All right, so let's evaluate some of these constants. Remember what I said, negative 1 to any odd power is going to equal negative 1. So here we have negative 1 times negative 1 to the 5th power, which is negative 1. Then we're going to get the determinant of A23. Now, what in the world is the determinant of A23? Remember what I said earlier. A23 is the original matrix A if we took out the second row. We're taking out the second row and the third column, because ith row, J column, so A23 is the second row, third column. This matrix is, again, it's the original matrix taking out the second row in the third column. So that's 1, it's 1, 5, 0, negative 2. 1, 5, 0, negative 2. Now this is really easy because the determinant of this matrix, this is just 1, negative 2 minus 0, 5. Again, anything multiplied by 0 is 0. So it's really negative 2 minus 0, which is negative 2. So the determinant of A is equal to positive 1 times negative 2, which is negative 2. So the purpose of the cofactor expansion is really to take a really big and complex and complicated matrix, and we're going to try to get it. We're going to try to explain the determinant in terms of a 2 by 2 matrix, what we can all do by in our head. So that's right. So that's the end of this example. Now, if you want to do some other examples, try to use a cofactor expansion with perhaps the third row, or use a cofactor expansion with any row in any column that doesn't have zeros in it. Thank you so much for listening.